The next topic is process capability. Now, process capability is the ability of a process to meet the specification requirements. If it is able to meet the specification requirements, then the process is said to be capable. So before we even try to test for process capability, you must make sure that the process is in control. So process being in control is a prerequisite for checking whether the process is capable. So you have to keep these two concepts separate. Often students get mixed up between these two. So process being in control does not mean the process is capable. So you have to check that. When you're checking whether the process is capable or not, you should not confuse that with the process being in control, because if the process is not in control, you will not be checking for capability at all. You have your first order of business is to make sure that the process is in control. So we compute two different process capability numbers. One is called process capability ratio. The process capability ratio looks at the specification width, okay, upper specification minus lower specification. How big is the specification? Whether plus or minus 3 sigma will fit into that. If plus or minus 3 sigma will fit into it, then good. Your process variability is smaller than what is allowed in the specification, which is good. Now, a process to be capable, this ratio, if it is 1, then you normally won't consider the process to be capable, because that's barely meeting the requirement. So you want some tolerance, a cushion. So a target value that is normally used is 1.33. That is the minimum standard that is required. Now if you want superior standard, a 6 sigma quality, then you need to achieve 2 for this ratio. Now this one talks only about the process variance. This is not about process, whether the process is capable or not. This is whether the process variance is small enough for the process to be capable. So if it is 1.33 or more, then the process variance is small enough for it to be capable. So here is an example. Okay. Lower and the upper specification limits, and divide by 6 times the process standard deviation. Now this is 1.938, so process variance is small enough for the process to be capable. Okay, but we don't know whether the process is capable or not. Now for process capable or not, you need to compute process capability index, which goes by the notation C sub pk, where you divide the specification into 2 parts. The upper specification, the midpoint, and then midpoint to the lower specification, and then divide by 3 times the standard deviation, and you select the minimum of the 2. If this is 1, then it is barely meeting the specification, and the process will not be considered capable. Once again, the minimum standard is 1.33. The superior standard for 6 sigma process is 2. So here is an example where you take the upper specification limit to the midpoint divided by 3 times the standard deviation, and then x bar minus the lower specification limit, and then you select the minimum, and this is 0.67, means it is not capable. Now this process capability index checks for the target value also, whereas the C sub p tests only for the variance. So at this point, when you know that the process is not capable, you have 2 things to do. You have to first check whether process variance is small enough. Okay, the only problem is centering. If you now compute C sub p, and if C sub p turns out to be 1.4 or something like that, then you know that the process variance is small enough. The reason why we are getting a very low C sub pk is because of centering towards the x bar, required x bar. But if on the other hand, if C sub p turns out to be 0.9 or something like that, or even 1.2, which does not meet the 1.33 threshold, then you know that the process variance must be reduced. So you go and try to make process changes such that the process variance gets reduced, and then check for process capability again. Now this time, once you reduce the process variance, your C sub pk may sufficiently improve to be more than 1.33, in which case you're good. But even after reducing the variance and C sub p is more than 1.33, but C sub pk does not meet the threshold of 1.33, then variance is small enough, but you're still not capable. It is because of centering, and then as a second step you will now try to center the production process towards the midpoint of the specification, and then C sub pk will be sufficiently large, greater than 1.33.